Hello, I'm Muñoz. Let me explain the stream module in Node.js. The goals of the presentation are to apply the operations of the stream module in a correct way and to implement short programs using this module. The contents of this presentation are structured in this way. Let's start. A stream object models a channel or a stream of information. In a stream, we may write or send new data. Write refers to the fact that we may write a line of text or a block of information on a file, while send refers to the fact that we may send a message using a communication channel that is modeled by that stream. In the same way, we may read or receive data, because they are the companion operations from the two that we have previously mentioned. And all these operations are applied in a sequential way. And this explains why these objects are called streams, because the data is processed sequentially. In Node.js, there are multiple types of streams. Their operations and events depend on that type, so we'll explain types first and later on operations and events. Let us revise all these elements. To begin with, we should say that the documentation for this module is available at this address. We should carefully read all those documents because they are needed for regular programs. In this talk, however, we will focus only on the main types and operations. Let's start with the types. There are 4 types of streams: writable, readable, duplex, and transform. Writable streams are used in order to send or write information. There are many examples: the process standard output, the process standard error, HTTP requests when they are used by clients, HTTP responses when they are used by servers, writable files, etc. Readable streams receive or read information, as already explained in previous slides. Again, there are many examples: the process standard input, HTTP responses in clients, HTTP requests in servers, readable files, etc. Duplex streams combine all operations from writable and readable streams. A good example are TCP sockets, because they may send information using the write operations and receive messages using the appropriate operations provided by readable streams. Finally, the transform type is a duplex that may also modify the data in the read or write stages. A good example is an extension of a TCP socket that is able to encrypt or decrypt the information being transmitted. In regard to the main operations of writable streams, they are write, end, and destroy. Write is used in order to write data in the stream. It has a mandatory argument, the data itself being written. Optionally, we may specify the encoding and set a callback to be used when the write operation is ended. The end operation is used to close a stream, and it sends or writes first all data kept in the stream buffer. Differently, the destroy operation closes and destroys the stream, discarding the buffer data. So that's the main difference between these two operations, their management of the buffers. In regard to the main operations for readable streams, they are resume, set encoding, and pipe. Resume resumes a stream that was previously stopped using the pause operation, although there are a few streams that have been initially paused. For instance, the process standard input. So In order to use the process standard input, we should call resume. Set encoding sets the stream encoding. An example is UTF-8. So we should use this string in order to specify the encoding. By default, streams simply return data as sequences of bytes, and they are hard to manage in this way. Finally, pipe is used in order to push or receive information in that readable stream onto another destination writable stream. In regard to the main events for writable streams first, they are close and error. Close notifies that the stream has been closed. As a result, no other new event will be raised on that stream. Error simply notifies that an error has happened on a write attempt. The error is passed as an argument for the corresponding event listener, if there's any. And the main events for readable streams are close, data, and error. Close notifies that the stream has been closed. As a result, no other new events can be generated. Previously, the end event has been generated also. And this means that there are no new or readable data. The data event notifies that there are new available data that may be read or received. In case of communication streams, this notifies that we have received a message. Those data will be passed as an argument to the corresponding event listener. And finally, error notifies that an error has happened on a read attempt on this stream. The error, again, is passed as an argument to the event listener. Let's see a program that combines all these operations and events. We are importing the FS module and the OS module. We are asking for a file name, and we activate, using resume, the standard input stream. We specify that the encoding for the standard input is UTF-8, and we manage data events from the standard input stream. They are each one of the lines of text that the user has provided from the keyboard. Well, those lines of text are received in this listener for the data event, and they are passed as the argument for that listener. In those lines, we simply discard what's the end of line sequence of characters. And we get in RD the line without this trailing end line. So, in case of error, these two operations may generate an exception. We, with that file name, try to read the corresponding contents. And perhaps, if we have incorrectly introduced an invalid name, this attempt of reading the file will raise the exception. So, if we arrive to this part, we have already processed the previous file, and we ask for a new file name. Finally, when the user presses a given keyboard combination, the standard input will be closed. And on that event, we react showing this message on the screen. So, we are reading file names from the console, and we show the contents of those files on the screen. Let's conclude. Once this presentation is ended, the students should be able to apply the operations of the stream module in a correct way, and implement short programs using this module.